In section 5.1, we are going to be talking about calculating probability. So the first thing that we need to talk about is, what does that term probability mean? It's likely a term that you are familiar with already. Most people, when they hear the term probability, they think about the chance that something will happen. And that is indeed what we mean when we talk about probability. So some examples: the probability that a fair coin will land on heads. There's a 50% chance, right? There's the same chance that you get heads as you get tails. We call this an even chance. Weather reports for probability that tomorrow will be a rainy day is 60%. That's the chance that that event will occur. The technical definition of probability, when we talk about it mathematically, is a number between 0 and 1 that tells you how likely something is to happen. We're going to talk about two different ways that we can calculate probability. One is a theoretical method where we think about possible outcomes. The other is an experimental or an empirical method where we calculate probability based on data. Notation that you're going to see used here when we calculate probability is P, and then in parentheses, the event that you're looking at. Okay, so just to give you an example here, if I wanted to talk about the probability that a fair coin will come up on heads, I would write that capital P, heads in parentheses, whoops, and I would state that as a chance or a probability of 0.5. So when we think about possible values for a probability, these are going to range from 0 to 1, right? Because if you think about that in the way of a percentage, that means your lowest possible value has a 0% chance of occurring. That would be like me saying I'm going to roll a 6-sided die, and I want to find the probability that I roll a 7. That's impossible. There's a 0% chance, so its probability would be equal to 0. The other extreme, the highest value that I can have for a probability, is equal to 1, because that equates to a 100% chance that something will happen, and that means the event is certain. It will definitely occur. So an example of that would be, I'm going to roll a 6-sided die, and I want to know the probability that I get a number less than 7. Well, that's always going to happen with a 6-sided die. There's a 100% chance, so its probability would be equal to 1. Everything else is going to fall somewhere in between. So the probability that we get heads on a fair coin, we said that was 0.5. That's like a 50% chance. That's going to fall right in the middle, right? An even chance. There's just as likely to get heads as they are to get tails when a coin is flipped. Values of probability that are closer to 0 are considered unlikely events. Probability values that are closer to 1 are considered likely events. So it's really kind of like a scale that we are defining, where 0 says it can't happen. Values between 0 and 0.5 say it can happen, but it's not incredibly likely. And then values between 0.5 and 1 say not only can it happen, but there's a pretty good chance that it will. All right, so we said we're going to talk about different ways to calculate probability, and that the theoretical method is one where we will look at possible outcomes. So the first thing that we need to define here is what we mean when we talk about a sample space. Sample space is a set where you list all the possible outcomes for the experiment. So if I want to define the sample space, when I toss a coin, there are 2 outcomes, and all I'm going to do is write a set. I'm going to call it S for sample space, enclose the outcomes in brackets, and I'm just listing them out. The only thing that can happen when I toss a coin is I get heads or tails, so that makes up my sample space. the roll of a die. If I'm looking at, a typical 6-sided die, then again, I'm going to write a sample or a sample space, a set, and I'm just going to list each possible outcome for that experiment. And that would be my sample space. All right, we can also have sample spaces that are a little more general where we can't actually list each one out, or it would just be really, really big. And so in that case, we just want to think about the possibilities. If I'm looking at selecting a student at random from a list of 10,000 students, then in that case, I'm just going to state that the sample space would include each of the 10,000 students at this university. Because what becomes important when you start finding probability is the number of outcomes. And so I could look at the sample space and I could know for A, there's 2 outcomes. For B, there's 6 total outcomes. And for C, there are 10,000 possible outcomes. Now, when we start looking at probability, we usually focus in on what we call an event. And an event is just a collection of some of the outcomes in that sample space. For example, we roll a die, the sample space is 1, 2, 3, 4, 5, 6. We might be interested specifically in an event of rolling an odd number. So that would include some of the outcomes, right? Rolling an odd number would include the 1, the 3, and the 5. And that collection of outcomes, 1, 3, and 5, odd numbers, would be considered an event because it's some of the outcomes in the sample space. All right, so we've talked a little bit about sample spaces already. Let's look at an example here where we need to determine what the outcomes are going to be. So notice in this example, we have 2 things that are happening. We're going to toss a penny and we're going to toss a nickel. So we have 2 coins. Each one is fair. And we want to construct a sample space where we list the outcomes. Now notice your note here. Each outcome has to look at both coins. So when you list your sample space and you list your outcomes, you have to make sure that you're looking at the entire experiment in each one. Now, for this situation, I only have 2 coins, right? It's not going to be too terribly difficult for me to just list them out. Right? So I'm going to write my sample space S. I'm going to list the first possible outcome would be that both the penny and the nickel are heads. Just thinking about other possible outcomes, I could have the penny heads and the nickel tails. I could have the reverse of this, or I could have a situation where both the penny and the nickel come up tails. Now, if you ever have trouble figuring out what your outcomes should look like when you have more than one thing happening, you can use a tool called a tree diagram, where basically you start and you just look at the first item, right? If we're just thinking about a penny, the outcomes would be heads or tails. And then we can go back and look at the second piece, which is the nickel. Its outcomes would also be heads or tails, but I'm going to branch that off from the previous outcomes. And then notice if I just follow along the branches, I get heads, 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 tails, tails, heads, tails, tails. And like if you had a third coin, if you had a dime that needed to be thrown in here as well, you could keep this going, right? You'd branch off heads and tails again for however many different items you need to look at. All right, the main thing here is by using the sample space, we can determine the number of outcomes, right? We wrote them out in our sample space here, and we see there are 4 total outcomes in this sample space. Now, if we want to look at particular events, for example, we want to look at the event that at least one coin is heads. All right, at least one means one or more comes up heads. So the outcomes that would be included there would be anything that has at least one H in it, right? So it could have one H in it, it could have 2 H's in it. So the outcomes that would be included would be both heads, or either case where one coin is heads. So looking at my sample space, I can determine that 3 outcomes would be included. And if I want to look at the situation where no coins come up heads, then I can see that only happens one time here. And so I would say that includes only one of the outcomes in my sample space.